Hello everyone, welcome back to IZTWF YouTube channel. I just received a nice packet from, well, it's coming from the United States, but it took some time to arrive. I just got all the nice Data I/O 2100 device programmer, which is not working, and I plan to repair this very nice programmer. Probably will make a video about it. Since the current situation in Italy, most of my projects are stuck because I'm waiting for something to arrive from abroad, and well, it's almost all shut down in Italy at the moment. So I have some C64 repairs ongoing, need parts. I have the Atari Asteroids also needing parts for the monitor rebuilding and stuff. So I'm almost stuck with everything. So I thought I will try to repair this Data I/O 2900 device programmer, and maybe this one will need no spare part that I don't have in stock in my collection. So who knows? Let's see what happens. In case you're wondering why I've been looking for a Data I/O 2900 or a very similar programmer for a few years, I've linked in the description this product brochure of 1990, where this programmer was first marketed. Back then it could program nearly every IC of the electronic world. This unit I've got has memory expanded to 8 MB of RAM, and there also was an internal hard drive option that I plan to copy one day. The programmer is powered by a Motorola 60000 CPU running at 8 MHz and has a 1.44 MB floppy disk drive to load the operating system and programming algorithms. It has 2 serial ports to interface with computers, and there was an option to add a parallel port for greater upload and download speeds. I haven't been able to find the price list for 1990 Data I/O products, but on the 1988 price list, the very similar but more capable Unisite model was priced at more than 11,000 US dollars without any option. Oh, and by the way, the programming adapter socket can be changed to allow, for example, programming of SMD chips. Now, this is a very complex electronics device. Not only is a complete 16-bit computer, but it's full of custom chips and is also built with SMD components. However, the price was good, and I have all the other Data I/O programmers, and their overall quality is outstanding. Plus, there is still a large user base of these programmers, and there is also a dedicated group on Groups.io, and as always, links are in the description of this video. So I thought I will take a chance and see if I can repair this. First of all, this seems to be completely dead. Let's power on. You see a power LED comes up, but nothing else. Even the self-test doesn't light up. The floppy drive doesn't even start moving, does nothing. So it's time to crack it open. To remove the top cover, we have one screw here, another here, which are kind of obvious, but also there are 3 screws that are covered in the top form, and this has already been removed, probably because of a previous repair attempt. And one screw is here, then we have another one here, and a third one here. that top cover is off, we have to remove these 3 screws next to the bottom panel. This one, this one, and this final one. And all the PCB boards can be lifted together. Pay attention that these boards are joined here. There is a long connector, but first you must lift both the two PCBs, then you can separate carefully the two parts, because there are some plastic supports here that need to slide out of this assembly for these two boards to be separated. So then after we separate the boards, we can see what's inside and start finding bad components and shorting the 5-volt rails. A device programmer like this needs many different DC power rails. In this case, the engineers choose to have a single supply voltage, which is 15 volts, generated from an offline switching power supply, and then a set of DC-DC converters located on the main control board that generate all the needed power rails. In this unit, the 15 volts from the main power supply are present, but almost no other rail is present. A good troubleshooting should always begin with a careful visual inspection of all the boards. And sure enough, that dark spot on the yellow SMD tantalum capacitor is suggesting that it may be part of our problem. Unfortunately, that capacitor is right under the big heatsink. So I must remove the heatsink before having enough clearance to safely substitute this capacitor. The heatsink is secured to the PCB with these 3 screws that must be removed. Then each power component screw must be removed also, and we need to pay attention to the insulating pads, avoiding damaging or misplacing them. Also, each of the screws has a plastic spacer to prevent the contact between the screws and the component metallic tab, and we don't want to lose any of those spacers. After removing the heatsink, we can remove the back capacitor and replace it. Then put back the heatsink. After tightening each of the component screws, we check with the multimeter that none of the tabs shows any continuity with the heatsink. Okay, then I have just connected the main power input and tried to power up again. So far so good. The self-test LED now comes on, and so I can try connecting the fan and the floppy disk drive again. And when powered down, the unit is booting from the floppy disk, so everything is good. Next step, on this website, link in the description of course, there is a copy of the latest available software revision for this program. The archive contains 4 Windows executable programs that will make 4 floppy disks. These floppy disks contain all the required boot code and programming algorithms. Then the programmer must be connected from the port labeled Terminal A to a computer running a serial terminal emulator program. I'm using Minicom on my Linux laptop. I have used the serial to USB adapter. The serial port on this program have an auto-sensing pinout, so you can use either a straight-through cable or an ARM modem one. Serial communication parameters default to 9600 bits per second, 8 data bits, no parity, and 1 stop bit. After booting with the 8.0 software revision, the programmer asked whether I would also want to update the firmware EEPROMs, and of course I happily did that. The boot disk contains also a complete set of hardware tests, and unfortunately the last test was always failing. On the group's I/O mailing list, everyone was suggesting that I should remove the socket adapter and try cleaning the contacts, but no amount of cleaning will do any difference anyway. I had forgotten a very important step during the first inspection of the various circuits boards. Luckily, the issue soon started to be apparent as the programmer was often failing to power up, and at one point it was again stone dead, without even the power LED coming on this time. Now I know how lucky I've been that the power supply didn't fail during the firmware E2 EEPROM's upgrade. The lack of the 15 volts main supply points directly to the little switch mode power supply mounted on the bottom of the case. As I said, inspecting this power supply should have been the first thing to do, even if, like in this case, it appeared to be working fine at the beginning. Here the issue is evident from the filthy and smelly substance leaking from the 4 electrolytic capacitors. The highly corrosive liquid also arrived to the pins of those other components. The first thing to do is, of course, remove the bad capacitors, and for the records they are Nippon Chemicon branded. Then the PCB must be carefully cleaned. I prefer to use an old toothbrush and isopropyl alcohol. If too much oxide has grown on adjacent component pins, then it's better to remove this component and clean them separately, like I had to do with IC51. It can happen that some of the soldered mask gets removed. This is the enamel covering the copper traces, which is green in this case. It's always a good idea either to apply some light enamel to cover the exposed copper or apply some tin over the copper to avoid further corrosion and oxidization of the copper. Finally, I could replace the capacitors and assemble again the programmer. At first, I thought that the power supply issue had nothing to do with the test failing, but after that, the test was passing every time. So I think the noisy 15 volt supply due to the bad capacitors was causing that test to fail. So as the last part of this video, I thought I will demonstrate a little bit how this system works, both from the terminal emulation port, like in this case, and with the TaskLink software for Windows that can be downloaded from the data.io group files. So now the programmer is connected to my Linux laptop. I'm using Minicom. Well, this is the main menu. It just booted and completed the self-test. This programmer has quite a lot of fun. I'll try to remove most of the noise of the fan with post-processing the audio, but I'm not sure I would be able to do that anyway. I'd like to program an unusual device, but at this moment I cannot really order anything from anywhere. They don't bring most of the mail also. I'm sure you know. And so I'm just showing the menus, and I will show the TaskLink program after this, nothing more. I thought would not program a regular EEPROM, which is very easy to program with something almost something else. So what we have with this programmer, we can configure the system, of course, but what is interesting is we can transfer data from to the computer using a whole lot of formats. We have these formats, for example, which most of them I don't even know that they existed. I usually use the Intel formats to transfer images or from and to the programmer. Sorry for that. I must have touched the connector, the USB connector. Or JDEC, also the format when transferring PAL images or similar programmable logic devices. We can of course copy to floppy disks or the hard disk option if it's installed, and we can format disk, load files, duplicate disks, and transfer to the hard disk options if present. And by the way, I'm building internal hard disk option for this program, to which you will use a compact flash adapter. And so it's a big menu. I'm not going to make a tutorial, just to show you the look and feel of this interface to the programmer. And the first thing you will do would be probably select a device, and we have 3 pages of manufacturer list. So let's look on the next page. What did I Control N? Illegal key input. Let's try again. Yeah, that worked. You must get used to this interface anyway. Okay, do you recognize something? Some part that rings a bell to you on this list? I do, and I would like to program that part, but not easy in the moment to have the blank parts. So let's pick up regular EEPROM. Then after you pick up the part, it says it cannot access the algorithm files. There are 3 algorithm disks in this software set, so I would just insert at this point the disk containing the algorithm number 2. But let's see instead the TaskLink program on Windows. You have to go here first of all and enable the remote control. At this point we can start the TaskLink program, exit the terminal emulation, run the TaskLink program, but we also have to move the serial port from the terminal A to the computer B port on the program. Okay, so change the port and started the TaskLink, and let's try to connect to the program. Is what it says. Okay, so this is a much better method to use these programs, in my opinion, because you don't have to go to the menus, just select device, for example, in this case. But by the way, this revision, the last revision of this programmer software supports more than 9,000 devices. So well, it's a bit maybe the selecting device with the menus of the programmer was faster, but it's not impossible, of course. You have filters here. Yeah, I'm not very familiar with this software. You can do a lot of things here. Edit RAM, it means what you read on the program. Of course, you can do also view and edit RAM via the serial terminal emulation. You can do almost the same things, it's just a different interface. so it's up to you what you prefer. I of course tried both, and probably will settle down with depends when I have the Compact Flash emulator working, and see if it's more efficient to work with this program or with the terminal emulation. Anyway, this is not the last revision of TaskLink, of course. I'm not sure even if the TaskLink current revision supports this old programmer. And it's not a freeware. This version of TaskLink can be downloaded from the .io group file section. It's an old revision, but it works fine with the 2900 and the other programmers of the same era. So that's all for the moment. Hope you enjoyed. If you have any question about this programmer or anything else, just leave in the comment. And thank you for watching. See you next time.